Hello and welcome to this video. Today we're going to be talking about endotherms. These are organisms that can regulate internal body temperature. So examples include humans, us, lions, really most mammals will all have this feature. Yeah, and birds. Most birds will regulate their own body temperature. So we have thermoreceptors that detect change. Temperature changes. And our thermoregulatory center in the hypothalamus sort of sends a signal to carry out these changes. So our thermoreg center in hypothalamus carries out changes. We have loads of different mechanisms that to induce heat gain or heat loss. So let's do another sort of mechanism table. So too hot, too cold. So vasodilation. So this is when skin surface arterioles that run along your skin surface, they'll expand and they'll dilate, so more blood flows closer to your skin surface, and so more heat is lost via convection. So basically the heat can then pass through and then it basically almost evaporates away the heat. We sweat. As you may have learned in Year 12, water has a high latent heat of vaporization, so that means lots of energy is required to evaporate water. And so when we sweat, and the sweat evaporates away, that takes a lot of energy along with it, and which means that we can lose a lot of energy at that point. What else? We stretch out. So some mammals will stretch out. Again, this is to expose more of their surface area, so more heat can be lost. If the external environment is too hot, some of us are nocturnal, cooler at night, and so behaviorally they'll they'll hunt at night where it's cooler, and so they'll be less exposed to the heat. Yeah. If it's too cold, we have lots of different mechanisms again. We have shivering, rapid skeletal muscle contraction, which generates heat through respiration, and that heat can then be used to warm up the body. Our erect pili muscles, so the muscles that hold our hair, they contract, so they basically stand on end, which traps an insulating layer of air between our body, between our skin and the external environment. That air then acts almost as an insulation for us. Blubber, a thick layer which provides an extra insulation, so it limits heat loss. Increased metabolic rate, again that's mainly done by shivering. So that links to shivering, so more energy produced by respiration, and that energy is then used to heat us up. Huddling, so you may have seen penguins huddle, and this huddling, basically it limits the surface area that is exposed to the cold, and so less heat loss. Hibernation, lowering our own body temperature when we hibernate. This means that there's a lower metabolic activity in cold temperatures, and so enzymes aren't needed as much, so it doesn't really matter if the climate is cold. Basically, less respiration when it's hot, and more respiration when it's cold. That's the main key to take away from that. Panting as well in the hot, because again, similar to water when we talked about it in ectotherms where they increase breathing rate, panting will increase evaporation of water from the surface of lungs because of the high latent heat of vaporization, so it takes a lot of heat with it. Advantages and disadvantages of ectothermy include advantages, disadvantages. So the body temperature is fairly constant. And as just on a slightly unrelated note, as we all know about fevers is where the pathogens increases your body temperature, and so that means that basically your higher body temperature allows for the pathogenic enzymes not to work, and so it kills the pathogens, and it's basically a way of our body to fight off infection. So they remain active in cold, another advantage, whereas ectotherms wouldn't be able to, because then their body temperature would be too low. So this means that they can live in colder environments, like polar bears and Arctic foxes. You're less likely to see ectotherms in the cold. Lots of energy is required. So more food needed. Less energy for growth. And they may overheat. In a hot environment. Peripheral temperature receptors are really important because they're on our skin. And what they can do is they can warn the thermoregulatory center that there is a change in temperature coming. So it allows for the brain to initiate mechanisms for maintaining that temperature. So it's basically the warning symbol. Cool. Thank you for watching. Hope to see you guys next time. Hope you enjoyed that. Thank you.